For centuries, humanity believed the universe was a quiet neighborhood. Stars were distant lamps, planets were rare accidents, and our solar system felt like a private island floating in cosmic darkness. We learned to map the sky, measure distances, and calculate orbits. Yet one assumption remained mostly untouched. Everything we observed belonged here, born here, found here. Then something strange passed through. 3IATLAS did not arrive with noise or warning. No explosions, no cosmic announcement. It simply appeared, already moving fast, already leaving, already indifferent to our expectations. Its trajectory did not curve the way local objects do. Its speed was not polite. It did not slow down to greet the sun, nor did it bow to gravity in the familiar way asteroids and comets usually do. This was not a visitor from the outer edges of our solar system. This was a traveler. What 3IATLAS teaches us first is not about rocks or ice or chemistry. It teaches us humility. The universe is not centered around our convenience, our models, or our assumptions. Objects can cross vast interstellar distances without caring whether we are ready to understand them. Reality does not wait for consensus. For a long time, we assumed interstellar space was empty in any practical sense, a cold void separating star systems like islands in a dark ocean. 3IATLAS quietly dismantles that idea. If one object can pass through, then countless others must have passed before it. We simply were not looking carefully enough. Or perhaps we were looking, but only for things that fit our expectations. This object forces us to confront a deeper truth. The universe is not static, it is migratory. Stars move. Galaxies collide. Planets are ejected from their birth systems. Debris whirls, and fragments wander freely through the Milky Way like cosmic nomads. 3IATLAS is not an anomaly. It is a messenger from a process that has been happening for billions of years. Another lesson emerges when we look at its speed. Interstellar velocity is not just about movement, it is about history. To move as fast, 3IATLAS must have been accelerated long before it encountered us. Perhaps by a violent gravitational encounter, perhaps by a dying star, perhaps by forces we have not yet fully mapped. Its motion is a fossil record of distant events that happened around other suns, in other systems, in eras long before Earth formed continents or oceans. In that sense, 3IATLAS is older than civilization, older than language, older than memory. It carries no inscription, no message, no intent, yet it speaks volumes. It tells us that planetary systems are not sealed laboratories, they leak. They exchange material. The Milky Way is less like a collection of isolated bubbles and more like a dynamic ecosystem where matter is recycled, redistributed, and reshaped across unimaginable distances. This realization changes how we think about origins. If material can travel between star systems, then the ingredients of planets, even the chemistry of life, may not be strictly local. The universe may be more interconnected than we ever dared to imagine. Not through signals or communication, but through matter itself, quietly drifting, colliding, and merging. 3IATLAS also teaches us restraint. We are tempted to label quickly, comet, asteroid, anomaly, mystery solved, but true science knows when to pause. Some objects are not puzzles to be rushed. They are invitations to rethink the framework itself. The presence of an interstellar object passing through our system is not just data, it is context. It reframes the story we tell about where we are and how isolated we truly are. Perhaps the most profound lesson is this: the universe is not built for permanence. Nothing stays where it was born. Stars drift, systems unravel, objects escape, even galaxies are temporary arrangements in an expanding cosmos. 3IATLAS is a reminder written in motion, a reminder that movement, not stability, is the universe's default state. We did not summon it, we did not stop it, we barely noticed it in time. And yet, in its silent passage, it widened our perspective. This is not the end of the story, this is the beginning of a new way of seeing the cosmos. Once the shock of recognition fades, a deeper question rises quietly in the mind. How does something like 3IATLAS come into existence at all? Not as a label, not as a category, but as a journey. Because interstellar objects are not born travelers. They are made into travelers by violence, by chaos, by the restless mechanics of gravity itself. Every planetary system begins in relative order. A young star ignites, surrounded by a disk of gas and dust. Planets slowly assemble, carving paths, stabilizing orbits, creating a sense of balance. But balance in the universe is always temporary. Massive planets migrate. Stars pass nearby. Binary systems dance unpredictably. And when gravity loses patience, smaller bodies are flung outward, accelerated to escape velocity, exiled from their birthplace forever. 3IATLAS is likely the survivor of such an exile. This tells us something uncomfortable yet profound. Solar systems are not safe homes, they are launch pads. For every planet that remains, countless fragments are expelled. The Milky Way must be filled with these refugees, rogue planets, icy bodies, rocky shards, all drifting through interstellar space like embers from a cosmic fire. What makes 3IATLAS special is not merely that it escaped, but that it returned, not to its home, but to ours. Its trajectory carries a signature that cannot be faked. Hyperbolic motion is a confession written in mathematics. It says, I do not belong here. No gravitational handshake with the sun could have produced that speed. No local disturbance could have taught it that path. Its motion is a biography of another star system. And here, physics begins to challenge our intuitions. We are used to thinking of space as frictionless emptiness. But interstellar space is not nothing. It is thin, cold, and sparse, yet over millions of years, even the faintest interactions matter. Radiation darkens surfaces, cosmic rays restructure chemistry, ice sublimates, dust layers build and erode. By the time an object like 3IATLAS reaches us, it is no longer what it once was. It is a transformed relic, sculpted by time rather than place. This means our usual categories start to fail us. Is it a comet, an asteroid, a hybrid? Those words assume a shared origin within our solar system. 3IATLAS resists such simplicity. Its composition may reflect temperatures, pressures, and chemical environments we have never directly sampled. Studying it is like analyzing a fossil from a continent that no longer exists. Another lesson emerges here. The universe does not standardize its creations. We often assume that other star systems must look like ours. Rocky planets here, gas giants there, icy belts at the edge. But interstellar visitors carry the fingerprints of diversity. Their very existence implies that planetary systems evolve in wildly different ways. Some are violent, some unstable, some efficient at ejecting material into the galaxy. 3IATLAS is not just an object, it is evidence of variation. It also forces us to rethink scale. The distances involved are so vast that even calling this a visit feels misleading. The object did not come to us, we simply happened to be in the way. For millions of years, it traveled without witnesses. For a brief cosmic moment, our telescopes intersected its path. Then it continued on, indifferent to the attention. That fleeting encounter reveals a humbling truth. The universe is full of stories that intersect with ours only once. From a scientific perspective, this changes how we design our instruments and our priorities. If interstellar objects are common, then missing them is no longer acceptable. We must learn to recognize fast, faint, and unfamiliar trajectories. We must be ready not for the expected, but for the anomalous. 3IATLAS teaches us that discovery does not always arrive neatly packaged. Sometimes it arrives already leaving, and perhaps the most subtle lesson of all is this: knowledge has a velocity. If our understanding moves too slowly, reality will pass us by. The universe does not pause so we can catch up. It reveals itself only to those prepared to see the unexpected. As 3IATLAS faded from our instruments, it left behind more questions than answers. But that is not a failure. That is an invitation to expand our models, refine our theories, and accept that the cosmos is far less orderly and far more alive than we once believed. The journey does not stop here. There is a moment in every scientific revolution when the data stops being just data and starts becoming a mirror. Interstellar objects like 3IATL are exactly that kind of mirror. They do not merely add a new line to a catalog, they quietly question the story we tell ourselves about our place in the universe. For generations, humanity imagined itself as living inside a cosmic enclosure. Vast, yes, but ultimately bounded. The solar system felt like a complete chapter with a clear beginning and a clear edge. Beyond it lay empty space, interesting perhaps, but disconnected. 3IATLA dissolves that boundary without asking permission. Its presence forces a shift from a local universe to a connected universe. This is not a small psychological change. When we realize that material from other star systems can pass through our own, untouched and uninvited, the idea of isolation collapses. The universe becomes less like a collection of sealed rooms and more like a single flowing structure where matter and energy circulate freely. That realization carries philosophical weight. If objects can travel between stars, then history itself is mobile. Events that happened billions of years ago around stars we may never see can leave physical traces in our neighborhood. The past is not locked behind distance, it drifts. 3IATLAS also changes how we think about time. Human time is linear and personal. Years, lifetimes, civilizations. Cosmic time is layered. An interstellar object may be older than Earth's oceans, older than the moon, older than life itself. When such an object enters our system, timelines overlap. The ancient brushes against the modern. This intersection reminds us that we are latecomers. The universe was already active, dynamic, and evolving long before biology learned to think. 3IATLAS does not care that we have telescopes now. It would have passed through even if no one was watching. Our awareness is optional. The universe continues regardless. And yet, awareness matters because it changes us. The discovery of interstellar visitors subtly erodes anthropocentrism. We stop asking, what does this mean for us? And start asking, what does this reveal about reality itself? That shift is the hallmark of mature science. There's also a quiet emotional impact. Knowing that matter from another star system has crossed our skies creates a sense of cosmic intimacy. Not the dramatic kind imagined in science fiction, but something gentler and deeper. A reminder that the atoms around us are not unique, not special, not confined. The universe recycles its substance endlessly. In this way, 3IATLAS becomes a philosophical teacher. It teaches impermanence. Stability is an illusion created by short timescales. Over millions of years, everything moves. Orbits unravel. Systems exchange matter. Nothing stays in its assigned place forever. It teaches openness. The boundaries we draw between here and there, between ours and theirs, are conveniences, not truths. Nature ignores them effortlessly. It also teaches restraint. Faced with something unfamiliar, our instinct is to rush toward explanation. But some discoveries demand patience. Interstellar objects do not give up their secrets easily. They ask us to listen longer, observe more carefully, and accept partial understanding. There is a deeper implication here for the search for life. If material crosses star systems, then chemistry does too. Complex molecules formed in one environment may seed another. This does not prove life elsewhere, but it expands the pathways by which life could arise. The universe becomes less fragmented, more collaborative, not intentionally, not consciously, but inevitably. 3IATLAS is not evidence of intelligence, design, or purpose, and that is precisely what makes it powerful. It shows us a universe capable of complexity without intention, connection without coordination. As our instruments improve, we will likely detect more such objects. And with each one, the psychological distance between star systems will shrink. The galaxy will feel less abstract, less unreachable. In the end, 3IATLAS teaches us something profoundly human. Wonder does not come from answers alone, but from realizing how much larger the question has become. We did not expand the universe by discovering it. We expanded ourselves. At first glance, physics appears confident. Equations are precise, laws feel settled. Gravity pulls, momentum conserves, trajectories can be predicted. Yet objects like 3IATLAS expose a quiet truth beneath that confidence. Our physics works best inside familiar boundaries. The moment something arrives from outside, the edges begin to blur. 3IATLAS moves on a path that refuses domestication. Its hyperbolic trajectory is not just a technical detail, it is a statement. It tells us that our solar system is not a closed system. Energy and momentum can arrive from elsewhere, carrying histories we did not account for. This challenges how we model cosmic environments. Most of our simulations assume long-term membership. Objects are born into a system, evolve within it, and remain gravitationally loyal. Interstellar visitors violate that assumption. They enter briefly, interact minimally, and leave, taking their secrets with them. That forces a reevaluation of probability. If objects like 3IATLAS are common, then rare events may not be rare at all. They may simply be brief. Our detection bias, our tendency to notice slow, predictable, repeating phenomena, has shaped our worldview more than we realized. Fast, unbound objects slip through our awareness like shadows. Another physics lesson emerges from energy itself. To escape a star system requires enormous velocity. That velocity must come from somewhere. Often, it comes from gravitational slingshots involving massive planets or stellar companions. This implies that many planetary systems are dynamically violent. Calm, circular orbits are not universal. Chaos is not an exception, it is a phase. 3IATLAS carries that chaos encoded in motion. Its speed tells us about the architecture of its birth system: massive planets, unstable resonances, close stellar encounters. Without ever seeing that distant system, we infer its existence through kinematics alone. Motion becomes archaeology. There is also the matter of thermal physics. Objects born far from their stars are cold, dark, and fragile. Traveling through interstellar space exposes them to cosmic radiation for millions of years. This alters surface chemistry, creates insulating layers, and changes how such objects respond when they encounter a new star. When 3IATLAS approached our Sun, its reaction, or lack of one, became data. Did it heat? Did it outgas? Did it fragment? Each behavior teaches us how matter behaves under conditions we cannot recreate in laboratories. Here, physics meets limits. We cannot chase these objects easily. We cannot land on them. We often observe them only briefly from afar through filtered light. This forces science into a humbler mode, inference instead of control, and that humility is essential. 3IATLAS reminds us that laws are universal, but environments are not. Gravity works everywhere, yet the outcomes differ wildly depending on context. A small change in initial conditions, millions of years ago around another star, can determine whether an object ends up wandering the galaxy or staying home. This sensitivity echoes chaos theory, the idea that long-term prediction in complex systems is fundamentally limited. Interstellar objects are the physical embodiment of that principle. There is also a deeper implication for cosmic safety. If interstellar objects pass through planetary systems regularly, then impact risk cannot be assessed purely locally. Some threats may originate far beyond the Sun's influence. This does not mean danger is imminent, but it broadens the frame of planetary defense. Physics once again becomes about perspective. Perhaps the most important lesson 3IATLAS teaches physics is this: completeness is an illusion. Our models are not wrong, they are incomplete. They describe a universe we have mostly observed from the inside. Interstellar visitors show us what the outside looks like, briefly, imperfectly, and on their own terms. And in doing so, they push physics forward, not by breaking laws, but by revealing where those laws have not yet been fully applied. Astronomy has always been shaped by what it can see. For centuries, the night sky appeared orderly because our instruments favored the slow, the bright, and the predictable. Planets returned, comets reappeared, stars held their positions. The universe felt stable not because it was, but because instability moved too fast for our eyes. 3IATLAS exposes that blind spot. Interstellar objects do not announce themselves early, they arrive faint, fast, and often already on their way out. By the time they are detected, the clock is already ticking. This forces astronomy to confront a fundamental limitation. We have been watching the sky as if it were static, when in reality it is transient. This realization is transformative. Suddenly, sky surveys are no longer about mapping what is there, but catching what is passing through. Time becomes as important as location. Cadence matters more than depth. Speed becomes as critical as sensitivity. 3IATLAS teaches us that the future of astronomy is not just bigger telescopes, but smarter ones. Wide-field surveys that scan the entire sky repeatedly become essential. Algorithms must recognize motion patterns that do not fit familiar categories. Artificial intelligence is no longer a luxury, it becomes a necessity. The universe is throwing anomalies at us faster than humans can manually classify. And this changes the culture of discovery. In the past, a discovery might unfold slowly, observations spread over years, debates refined over decades. Interstellar objects compress that timeline. Decisions must be made quickly. Observation windows close rapidly. Collaboration becomes urgent rather than optional. 3IATLAS reveals astronomy as a race against time. There is also a philosophical shift in how we define significance. Not everything important is large or long-lasting. Some of the most informative objects are fleeting. Their value lies not in persistence, but in rarity and origin. This challenges a deeply ingrained bias that enduring structures matter more than transient ones. Interstellar visitors also push observational astronomy into new wavelengths. Visible light alone is not enough. Infrared reveals thermal history. Spectroscopy hints at chemistry. Subtle changes in brightness may reveal rotation, shape, or internal structure. Each photon becomes precious because there may not be another chance. The brief passage of 3IATLAS highlights an uncomfortable truth: we are not in control of the observing schedule. The universe does not wait for upgrades, funding cycles, or peer review. It presents phenomena when it chooses. This forces humility and creativity. Some have proposed rapid response space missions positioned to intercept future interstellar objects, not to land necessarily, but to fly by, sample dust, Measure composition directly. Such missions would mark a new era, proactive astronomy rather than reactive observation. 3IATLAS also changed how we think about archives. Past data suddenly becomes valuable again. If interstellar objects are common, then many may already be hidden in old surveys, misclassified, or overlooked. Discovery becomes retrospective as well as prospective. This is a profound shift. The universe may have been speaking all along, we just lack the vocabulary to hear it. At its core, astronomy after 3IATLAS becomes more dynamic, more alert, and more open to surprise. The sky is no longer a backdrop, it is a stream. And every observation is a potential encounter with something entirely foreign. The lesson is clear: to understand the universe, we must stop assuming it behaves politely. For a long time, planetary systems were imagined as orderly families, a star at the center, planets moving in stable, predictable paths, everything in its proper place, quietly enduring for billions of years. This image was comforting and mostly wrong. 3IATLAS shatters that illusion. An interstellar object is proof that planetary systems do not merely form, they shed. They eject material violently and permanently. To understand 3IATLAS is to accept that many worlds are born into chaos rather than calm. Planetary formation is not a gentle process. It begins in turbulence, collapsing clouds, swirling disks, competing gravitational forces. As planets grow, they do not always settle politely. Massive bodies migrate, resonances build, orbits destabilize. Smaller objects are scattered outward like sparks from a grinding wheel. 3IATLAS is likely one of those sparks. This means that every planetary system is, at some stage, a catapult. The Milky Way is filled with debris from countless such events. Some fragments become rogue planets, drifting starless through space. Others become smaller travelers, icy or rocky, carrying chemical signatures of their birthplaces. The lesson here is unsettling. Stability is earned, not guaranteed. Our own solar system may feel calm now, but evidence suggests it was once far more violent. Giant planets likely migrated early on. Entire populations of objects were displaced or destroyed. The fact that Earth exists in a stable orbit is not proof of cosmic kindness. It is proof of survival. 3IATLAS reminds us that for every system that settles, many do not. This has implications beyond mechanics. If planetary systems frequently eject material, then the galaxy becomes a mixing chamber. Elements forged around one star can end up near another. The boundaries between systems blur over time. This mixing may influence the distribution of complex chemistry. Organic molecules formed in cold, distant regions could travel vast distances before encountering new environments. While this does not guarantee life, it widens the field of possibility. Violence in the universe is not the opposite of creation, it is part of it. Another insight emerges when we consider scale. Ejecting an object like 3IATLAS requires massive energy, often involving giant planets or close stellar encounters. This suggests that many star systems host architectures very different from ours, with more massive planets, tighter configurations, or unstable resonances. In other words, our solar system may be the exception, not the rule. 3IATLAS carries indirect evidence of these unseen systems. Its speed, direction, and survival encode information about environments we cannot directly observe. It is a messenger from planetary systems that fail to remain quiet. There is also a sobering implication for habitability. Stable environments may be rarer than we assume. Worlds capable of sustaining life long enough to evolve complexity may exist only in systems that escape prolonged chaos. If so, life is not just about chemistry, it is about timing and dynamical luck. 3IATLAS does not answer whether life is common or rare, but it reframes the question. The universe may produce building blocks abundantly, while long-term stability remains scarce. Perhaps the most important lesson is this: destruction is not wasteful in the cosmos. What is ejected is not lost, it is redistributed. Matter travels, systems influence one another indirectly, and the galaxy evolves as a connected whole. 3IATLAS is not a mistake of formation, it is a consequence of it. When the word life enters a scientific discussion, imagination often runs ahead of evidence. Interstellar objects invite that temptation more than most discoveries. A traveler from another star system feels like a messenger, even when it carries no message. 3IATLAS forces us to confront this tension between curiosity and discipline. The first lesson is restraint. An interstellar object does not imply life. It does not suggest intention. It does not hint at technology. What it does suggest is something far more subtle and far more powerful: the mobility of chemistry. Chemistry does not stay put. Molecules form in cold molecular clouds long before stars ignite. Ices accumulate on dust grains. Complex organic compounds assemble in darkness and silence. When planetary systems form, some of this material becomes incorporated into planets, moons, and small bodies. But not all of it stays home. 3IATLAS represents chemistry on the move. Over millions of years in interstellar space, its surface has been processed by radiation and time. Bonds break, new ones form. layers build and erode. This slow transformation creates chemical environments we cannot easily reproduce. When such an object enters a new system, it carries that history with it. This reframes panspermia not as a claim but as a mechanism. Panspermia does not require life to be common or intentional. It only requires that complex molecules can survive travel and encounter new environments. Interstellar objects demonstrate that long-distance transport of material is not speculative, it is observable. But there is a critical distinction: transport does not equal seeding. The presence of organic molecules does not mean life will arise. Chemistry is permissive, not deterministic. Conditions must align precisely for life to emerge. Temperature, stability, energy gradients, and time all matter. 3IATLAS expands the supply chain, not the guarantee. This is an important correction to sensationalism. The universe does not whisper secrets of aliens through every anomaly. It reveals processes. And those processes are often more interesting than the fantasies built around them. Another insight emerges when we consider survivability. Interstellar space is harsh. Radiation is relentless. Temperatures are extreme. Most biological structures would not endure such journeys intact. If life travels, it does so under severe constraints. This pushes the conversation away from organisms and toward prebiotic chemistry, the stage before life. Molecules are more resilient than cells. They can endure conditions that living systems cannot. 3IATLAS is a courier of possibility, not proof. There is also a broader implication for origins. If material circulates between star systems, then planetary systems are not chemically isolated experiments. The galaxy becomes a shared laboratory. Innovations in chemistry discovered in one region can, in principle, influence another. This makes the emergence of life less parochial and more universal. Not guaranteed, but less confined. At the same time, 3IATLAS teaches humility. We may never know its exact composition. We may never trace it back to its home star. Some questions remain permanently out of reach. Science advances not by eliminating mystery, but by learning which mysteries matter. Perhaps the deepest lesson is psychological. Interstellar objects remind us that the universe does not need life to be interesting. Complexity arises naturally. Connection emerges without intention. Meaning is something we bring, not something embedded, and yet the fact that chemistry can wander between stars quietly widens the stage on which life might appear. Not promised, not predicted, but possible. Humanity's plans for space have always been shaped by proximity. We explore what is close, reachable, and predictable. The Moon, then Mars, then perhaps the outer planets. Interstellar space has remained a distant abstraction, something to observe, not to touch. 3IATLAS quietly changes that hierarchy. It introduces a new category of target, the passing outsider. Interstellar objects are not destinations in the traditional sense. They do not wait in stable orbits. They do not offer long preparation times. They appear briefly and depart forever. This forces a new philosophy of exploration, one built around readiness rather than long-term planning. 3IATLAS teaches us that the future of space exploration may belong to speed and flexibility. Rapid response missions become meaningful. Spacecraft designed to launch quickly, alter trajectories efficiently, and collect data on the fly move from speculative ideas to strategic necessities. The goal is not colonization or permanence, but encounter. Encounter itself becomes valuable. A flyby of an interstellar object would allow direct measurement of material formed around another star. Not inferred, not modeled. Touched. Even a few minutes of close observation could rewrite textbooks. This also reframes cost-benefit thinking. Traditionally, missions justify themselves through longevity. Interstellar encounters justify themselves through uniqueness. One chance may be worth more than 100 routine orbits. There is a deeper strategic implication. If interstellar objects are common, they represent a continuous sampling of the galaxy delivered to our doorstep. Nature performs the transport, we only need to intercept. This is not interstellar travel in the science fiction sense. It is interstellar science without leaving home. 3IATLAS suggests a future where we learn about distant star systems without traveling to them. This has profound consequences for long-term planning. Instead of waiting centuries to reach another star, we can study fragments from many stars over decades. Each interstellar object becomes a data point in a galactic survey. The lesson is efficiency. There is also a cultural shift embedded here. Exploration is no longer only about expansion outward. It becomes about attention inward, watching carefully, responding quickly, recognizing opportunity when it appears. This aligns with a broader truth: progress does not always require distance, sometimes it requires timing. 3IATLAS also challenges institutional inertia. Space agencies are built around long timelines, fixed missions, and predictable objectives. Interstellar objects do not respect bureaucracy, they demand agility. Collaboration across nations, disciplines, and agencies becomes essential. In this sense, the object does not just move through space, it moves through systems, scientific, political, and cultural. There is also a symbolic dimension. Encountering material from another star system is a reminder that humanity is already participating in a galactic process. We are not waiting for the future to arrive, it is already passing by. And perhaps the most important lesson for exploration is philosophical. The universe does not need to be conquered to be understood. Sometimes, understanding arrives uninvited, briefly illuminated, then gone. Our task is not to control that process, but to be ready for it. 3IATLAS teaches us that the next great discovery may not be where we are going, but what is coming to us. Science is often portrayed as a march towards certainty. Each discovery adds clarity, sharpens definitions, and closes gaps. But the universe does not always cooperate with that narrative. Some discoveries do the opposite. They widen uncertainty. 3IATLAS belongs to that rare category. From the moment it was detected, ambiguity followed. Its origin could not be traced to a specific star. Its composition could only be inferred indirectly. Its history was written in motion, not in records. And its future was already decided, departure without return. 3IATLAS teaches us that uncertainty is not a flaw in science, it is a feature of reality. There are limits to observation, limits to time, limits to resolution. Interstellar objects expose those limits clearly and unapologetically. They remind us that some questions cannot be answered simply because the universe does not preserve the evidence long enough. This is not failure. This is honesty. Scientific maturity is not about eliminating uncertainty, it is about learning how to work within it. 3IATLAS becomes a case study in disciplined restraint, in resisting the urge to overinterpret limited data. This matters deeply. In an age of instant analysis and public speculation, the temptation to fill gaps with confident narratives is strong. Interstellar objects resist that temptation. They remain partially unknowable, no matter how advanced our tools become. And that forces a cultural correction. Science does not promise completeness. It promises rigor. It promises transparency about what is known, what is inferred, and what remains unresolved. 3IATLAS sharpens that distinction. There is also an epistemological lesson here, a lesson about how knowledge itself is structured. Some information is recoverable, some is permanently lost. The past does not always leave a readable trace. The universe does not archive its processes for our convenience. Interstellar objects pass through, interact briefly, and leave, taking with them context we can never reconstruct fully. Their partial opacity is not a failure of method, it is a consequence of scale. This teaches humility, it also teaches patience. Each new interstellar object will add a fragment to a larger picture. No single discovery will resolve the question. Understanding emerges statistically, not individually. Patterns matter more than anecdotes. 3IATLAS shifts our expectations from answers to frameworks. There is a deeper psychological insight here. Humans are uncomfortable with not knowing. We prefer closure. Interstellar objects deny closure. They remain open-ended, unresolved, incomplete. And yet, that incompleteness is productive. It forces us to refine detection methods. It encourages broader models. It pushes us to think probabilistically rather than narratively. It moves science away from storytelling and towards structure. Perhaps the most important lesson is this: mystery is not the enemy of understanding. It is often its starting point. 3IATLAS does not explain the universe. It destabilizes our assumptions about it. And in doing so, it makes space for better questions. Questions that acknowledge complexity rather than oversimplify it. The universe, it seems, is not obligated to make sense on our schedule. Every era of discovery quietly reshapes how humanity sees itself. The Copernican revolution removed Earth from the center. Evolution removed humanity from biological exception. Interstellar objects like 3IATLAS continue this pattern, not dramatically, but persistently. They tell us we are not isolated. For most of history, the solar system felt like a complete stage. The sun rose, planets moved, comets returned, and the cosmos seemed vast but detached. 3IATLAS punctures that sense of enclosure. It shows that our system is porous, open, and continuously intersected by material from elsewhere. This has consequences for identity. We are not inhabitants of a sealed world. We live in a region of a galaxy where matter flows freely. The atoms beneath our feet are part of a circulation that extends far beyond the sun's influence. Even Earth itself may carry material that once belonged to other stars. This realization shrinks and expands us at the same time. It shrinks us because it erases uniqueness. Our environment is not special by default. It expands us because it connects us to a much larger process. We are not separate from the galaxy, we are embedded within it. 3IATLAS reinforces a recurring cosmic lesson. Belonging does not require centrality. Human significance does not come from being at the center of the universe. It comes from awareness, from the ability to notice, question, and reflect on phenomena that do not care whether we exist. There is also a moral undertone here. When we recognize that we are part of a dynamic, interconnected cosmos, parochial concerns begin to look smaller. Borders, divisions, and short-term conflicts lose some of their perceived permanence. This is not idealism, it is perspective. 3IATLAS does not preach unity, it reveals scale, and scale changes values. Another layer of identity emerges when we consider responsibility. Awareness brings obligation. As our understanding deepens, so does our role as stewards, not of the universe, but of our capacity to understand it. We are the part of the universe that can ask questions about itself. That is not destiny, that is circumstance. 3IATLAS passed through our system without intention, yet it triggered reflection. That reflection is uniquely human. It defines our role not as rulers or conquerors, but as witnesses. This reframes ambition. The goal is not to dominate space, but to comprehend it honestly. To accept our smallness without surrendering curiosity. To recognize limits without abandoning exploration. There is a quiet dignity in that position. Perhaps the most subtle identity shift is this: we stop thinking of the universe as something outside us. It becomes something we are already participating in, breathing, moving, observing, evolving. 3IATLAS is not a visitor to humanity. It is a reminder that humanity is already a visitor in a much larger story. Interstellar objects like 3IATLAS have a unique place not just in science, but in the human imagination. Their fleeting passage captures headlines, sparks speculation, and ignites dreams about extraterrestrial life, cosmic visitors, and the mysteries of the universe. Yet, this fascination comes with a responsibility. Popular culture often turns such discoveries into grand narratives of alien ships, cosmic messages, or hidden conspiracies. While these stories entertain and inspire, they can also distort scientific understanding and raise expectations beyond evidence. 3IATLAS reminds us of the importance of restraint and imagination. The boundary between wonder and speculation is thin. Maintaining scientific rigor requires resisting the temptation to fill gaps with fantasy. This does not diminish the excitement, it deepens it by grounding awe in reality. The media plays a crucial role here. How discoveries are framed shapes public perception. Headlines promising proof of aliens or cosmic mysteries solved may attract clicks, but ultimately undermine trust when science reveals nuance and uncertainty. 3IATLAS challenges communicators to balance engagement with accuracy. There is also a cultural opportunity embedded in this challenge. Interstellar visitors can serve as gateways to science education. Their story connects physics, astronomy, chemistry, and philosophy in a way that is accessible and compelling. By focusing on the genuine mystery, the vast timescales, and the cosmic perspective, educators can inspire curiosity without oversimplifying. This shift benefits both science and society. Imagination thrives on mystery, but it flourishes best when tethered to facts. 3IATLAS' story encourages a type of wonder that asks questions rather than demands answers. It invites participation, not passive consumption. Moreover, these discoveries emphasize the human trait of patience. Unlike fictional tales of instant contact or rapid revelation, science progresses through gradual understanding. Interstellar objects often yield subtle clues that accumulate over time. This counters a cultural impatience that favors immediate results. Finally, 3IATLAS reminds us that the universe's greatest stories may be quiet and slow-moving. The passage of a small object through our solar system may lack drama, but carries profound meaning for those willing to listen carefully. It teaches us that the extraordinary often appears in subtle forms. As such, it shapes not just science but our collective imagination, fostering a humility and openness essential for future exploration. The search for extraterrestrial intelligence, C2I has long focused on detecting deliberate signals, beacons sent across the void by advanced civilizations. Yet, 3IATLAS introduces a different dimension to this quest: the idea that evidence of other worlds might arrive unannounced, unintentional, and purely physical. Unlike radio waves or laser pulses, interstellar objects carry material footprints, the tangible remnants of other star systems bearing the scars of their origins and journeys. They are cosmic postcards without messages, but with stories encrypted in composition and trajectory. This shifts the SETI paradigm from listening for signals to watching for signs. The existence of objects like 3IATLAS suggests that intelligence, if it exists elsewhere, may not be sending clear communications, but its presence might still be inferred through indirect means: patterns in object behavior, unusual compositions, or technologies embedded in materials. Yet, this possibility is tempered by caution. Natural processes alone can explain most observed phenomena. The burden of proof lies heavily on demonstrating that an object's characteristics defy known physics and chemistry. 3IATLAS so far fits within natural expectations, reminding us of the importance of rigorous skepticism. Moreover, the fleeting nature of such objects limits detailed study. The opportunity to investigate is often brief, demanding rapid mobilization of observational resources, a challenge for traditional, slower-moving scientific programs. This reality underscores the limits of our current detection methods. Our instruments are designed primarily for the predictable and repetitive. Interstellar visitors demand agility, both technical and institutional. to catch them in transit and extract meaningful data. 3IATLAS thus highlights the need for new approaches in SETI and planetary science, combining rapid response, multidisciplinary collaboration, and innovative technology. There is also a philosophical implication. The universe may not be broadcasting in Morse code or laser flashes. Instead, it may be whispering its history through wandering fragments, subtle anomalies, and natural artifacts traveling through space. Recognizing this requires broadening our definitions of evidence and expanding our horizons beyond conventional signals. 3IATLAS invites us to imagine intelligence not just as a transmitter, but as a participant in a cosmic environment, one that leaves traces, intentional or accidental, within a vast and dynamic galaxy. In this sense, the search for life and intelligence becomes intertwined with the study of interstellar objects themselves. By observing them, we are not merely cataloging space rocks, we are exploring the tapestry of cosmic history, woven with countless threads from stars, planets, and perhaps civilizations yet unknown. Ultimately, 3IATLAS teaches patience, rigor, and openness in the quest for understanding. The discovery of 3IATLAS reveals the galaxy as not merely a collection of isolated star systems, but as an interconnected web, a dynamic ecosystem of material exchange. This perspective reshapes how we understand the flow of matter and energy on galactic scales. Stars are born, evolve, and die, ejecting gas and dust that seed future generations. Planets form within these systems, but as 3IATLAS demonstrates, not all material remains bound. Some fragments escape their homes, becoming interstellar wanderers. This wandering matter acts as a courier, carrying elements and compounds across vast distances, enabling chemical mixing on scales previously unappreciated. The galactic ecosystem, therefore, is one of recycling and redistribution. This has profound implications for everything from the formation of planetary systems to the potential distribution of life's building blocks. 3IATLAS is a tangible proof that matter is not confined by stellar borders but flows between them. This challenges older models which treated star systems as largely closed chemical factories. Instead, it supports a view of the galaxy as a communal chemical workshop where ingredients are shared, transformed, and passed along. Such exchange likely affects the chemical diversity observed in planetary systems. It may influence planet formation, surface compositions, and atmospheres, adding layers of complexity to the birth environments of potential habitats. Moreover, the flow of material across the galaxy suggests a form of cosmic connectivity, where the fate of one system subtly influences others. This interconnectedness extends to the potential for panspermia, where organic molecules or even primitive life could traverse star systems embedded in objects like 3IATLAS. Understanding this galactic ecosystem requires a multidisciplinary approach combining astrophysics, chemistry, planetary science, and biology. 3IATLAS acts as a bridge linking these fields through direct observation of material in transit. It urges us to reconsider the scales and boundaries of cosmic processes, from the intimate formation of molecules on dust grains to the grand circulation of matter across the Milky Way. In doing so, it elevates our conception of the galaxy from a static backdrop to a vibrant, evolving system rich with movement and exchange. Ultimately, 3IATLAS teaches us that the universe is more interconnected than our models often assume, and that every piece of matter carries the legacy of a journey far beyond its origin. The fleeting visit of 3IATLAS has spurred rapid innovation in technology, reshaping how we observe and study the cosmos. It has revealed both the limitations of existing instruments and the urgent need for new capabilities designed specifically to detect and analyze transient interstellar visitors. Traditional telescopes optimized for static or slow-moving targets often struggle to catch such fast-moving objects early enough for detailed study. The challenge lies in the combination of faintness, speed, and unpredictability. To meet this challenge, astronomers are developing wide-field surveys with high cadence, telescopes that scan large portions of the sky repeatedly in short intervals, increasing the chances of early detection. Artificial intelligence and machine learning algorithms are becoming indispensable, rapidly processing vast data streams to identify candidate objects, filter out false positives, and prioritize targets for follow-up. Space-based observatories offer unique advantages, free from atmospheric distortion and capable of observing in wavelengths inaccessible from the ground. Missions dedicated to quick response interception of interstellar objects are being conceptualized, potentially allowing close-up study within months of detection. These technologies do not only serve interstellar visitors, but benefit broader astronomy by improving detection of near-Earth objects, transient phenomena like supernovae, and variable stars. The technological leap inspired by 3IATLAS reflects a shift from passive observation to active engagement, transforming how we interact with the dynamic universe. Moreover, this evolution fosters international collaboration as rapid data sharing and coordinated observations become necessary to capture these brief encounters. The investment in adaptive infrastructure signals a future where astronomy is more agile, responsive, and integrated. 3IATLAS thus acts as a catalyst, driving progress not just in knowledge but in the tools of discovery. The lesson is clear. Technological innovation is both a response to and a driver of scientific opportunity. As we build these new capabilities, we prepare not only to observe more interstellar objects but to understand their stories in greater depth, unlocking secrets about the galaxy's past and the processes shaping its future. 3IATLAS is more than an interstellar visitor, it is a teacher, silent, fleeting, and profound. Its journey through our solar system carries lessons that ripple across disciplines, challenging assumptions and expanding horizons. At its core, 3IATLAS teaches us about connection, between stars, between systems, and ultimately between ourselves and the cosmos. It dissolves boundaries, revealing a universe not of isolated islands, but of flowing rivers of matter and energy. It teaches humility, reminding us that despite our advances, much remains unknown. The cosmos is vast, complex, and often ambiguous, resisting simple explanations and inviting patience. 3IATLAS teaches curiosity without arrogance. It calls for disciplined wonder, a recognition that the universe's greatest mysteries often arrive unannounced and depart before we fully understand them. It challenges us to rethink identity, not as central or unique, but as participants in a grand dynamic process that stretches beyond any single system, species, or moment. Technologically, it propels us forward, urging innovation, agility, and collaboration in the quest to grasp the fleeting and the foreign. Philosophically, it invites us to embrace uncertainty and to find meaning not solely in answers, but in the questions themselves. In the final analysis, 3IATLAS embodies the spirit of exploration, not conquest, but encounter, not possession, but participation. It teaches that the universe is not a static stage for human drama, but a living, evolving story in which we have only just begun to read the first pages. And so, as 3IATLAS fades back into the depths of space, it leaves behind a legacy far richer than scientific data. It leaves us with a deeper sense of wonder and a renewed commitment to seek understanding, no matter how elusive. Our journey through the cosmos continues, guided by the lessons of this remarkable visitor, as we step forward into the unknown with humility, curiosity, and hope.